Hello world, it's me Abhinaya. So in this video we're going to solve another very interesting problem which is called permutations. It is a medium level problem in LeetCode. So let's see the question. Given a collection of distinct integers, return all possible permutations. So the input they'll give a list and we should return all possible permutations. So let's see how we are going to solve this problem. So I'm going to solve this problem using backtracking. So let's see. First, let me explain how I'm going to solve this problem and then we'll see the code. So first, let me take this example itself. We have three numbers in it, 1, 2, 3, and we should return all possible permutations of this list, right? So we have three positions, right? For first integer and for second integer and for third integer. For the first position, we have three choices, either 1, 2 or 3. So let's choose 1 for the first position. And for the second position, we have two choices, either 2 or 3. So for now, let's choose 2. And for the third position, we don't have any other choice. It has to be 3. So this is like this, right? First we have 1 and then we are adding 1 and 2, 1 and 2, and then we are adding 1, 2 and 3, right? So what we can do is this 1, 2, 3 is the first permutation of this list. And if we see in the second position, we have two choices, either 2 or 3. So first we chose 2, and for the next we can backtrack to this step 1 and 2, and we can choose 3 instead of 2, like this. We will backtrack from this step to this step and we will choose 3 instead of 2, and it will become 1 and 3, right? And for the next position, we don't have any other choice to choose. So it will be 1, 3 and 2. And these are the 1, 2, 3 and 1, 3, 2 are the two permutations of this list. And these 1, 2, 3 and 1, 3, 2 are the permutations as the first position as 1. And now we'll go back to this step. And we will So now we actually got the permutations for 1, 2, 3 and 1, 3, 2, which is for the first number as 1. And we have other two choices for the first, right? Now we solve for 1. And now we have 2. And we will backtrack to this step again. And we will change this to 2. And we will change this to 2. And the step continues as like this itself. And then it will go for 2 and 1 and 2, 1, 3, and we will backtrack again. We'll backtrack again and 2, 3, 1 like that. And it continues for all the integers in the list. And I hope you guys understood this. So let's do this problem. And how we're going to do is, first let's have a list. And this is going to be the result list, and this is going to store all kinds of permutations of the list, okay? And then we are going to call another function called backtrack. And in this function, we're going to pass another few things. I'll say that later, okay? And now the last step is going to be, we are going to return the R. That's it. The sum is over. Actually, no, we're going to solve this now only. And in the backtrack function, we're going to pass the nums, the input. And then we should have this result also, right, to store the permutations. And then we should pass an empty, and then we should pass an empty list so that we can store all these one permutation in the list, and we will append this empty list into the result list. Okay, for that we need this empty list. Let's see what we're going to do in this backtrack function. Backtrack, so first one should be self, and then nums is going to be nums, and this empty list I'm going to take it as path. I'm going to name it as path and the result. So to get the numbers one by one, so first we are taking it as 1, right? So for that, for first it's going to be, the first position is going to be 1, and then we're going to backtrack and it's going to be 2, and for that and all, we need a for loop. So for in range len of nums. Okay, then what we're going to do? That is very simple, guys. So now what we're going to do is, first what are we doing in this sum? First we are taking 1, right? And then we're choosing 1 for the first position. So now the path is going to be something like this, right? Path is going to be something like this, and the num is going to be like, num will have 2 and 3, right? And then what's going to happen for the second position, we're going to choose 2. So the num will be like this. And for the third position, we're going to choose 3, and the num will be empty. So this is what's going to happen. So what we're going to do is, we're going to call the backtrack again. Backtrack. So what's going to happen? So with the path, we are just going to add the nums of I, right? The first integer we're going to add it here, and then we're going to pass this result again. And then what we're going to do here is, what are we doing? So first, when we add 1 in the path, the num will have only 2 and 3. The num doesn't have 1 when the 1 is added to the path, the num doesn't have 1 in it, right? So when the 2 is added here, 2 is not present in the num, right? So what we should do is, we should pass the num except the integer which is added in the path. Okay, it will be like this. So we are passing the num except the integer which is added in the path. Okay, so we'll erase these things. So when you see this, when the first permutation 1, 2, 3 is added to the path, the num becomes empty, right? When the num is empty, we have got one permutation. So for all the backtracking problems, we'll always have a constraint, a basic constraint where we'll get the solution, right? So we're going to give that constraint. So when the num is empty, we've got one permutation, right? So we can see it like this. When num is empty, we got one permutation. So we can add that permutation to our result array. Part. And that's it, guys. This will return us all kinds of permutation. So first it will be like for 1, 2, 3 and 1, 3, 2, and next it will backtrack, and for 2, 1, 3, 2, 3, 1, and it will backtrack again, and for 3, and it continues for all kinds of integers in the nums list. Okay, so I hope you guys understood this. So let me run this problem. What is that? It's just a small spelling mistake, guys. It's just clean it with it. Let's run it again. So let's run it. We have got the solution correct. Let's submit it. So it's correct, guys. So I hope you guys understood this problem, and I will come with another exciting problem in my next video. Until then, bye.